Sometimes we can use this ijk to find out relative velocity, or sometimes we'll have to use the other means, right? So it's very simple to use this ijk formalism for some cases, right? But we'll see that when do we have to use the other ones. So we'll look at those. So let's say for the 71st question, right? For 71st question, find the velocity of car B relative to car A, right? So we have to find VBA, both in magnitude and direction. So we see that we can simply write, right? We can simply write in this question, in the IJK formalism, this would be pretty easy, right? If we write the IJK formalism, so this will be very, very easy. So let's say what is VA, right? What is VA in IJK formalism? So magnitude is 40 kilometer per hour. And what is the direction? What is the direction? So north, south, and east and west, right? So what is the direction? Yes, guys. So this is J hat. Simply what is B? BB is simply that is going in the east direction. So that is simply 30 I hat, right? And if we want to find out velocity of B with respect to A relative to A, so this is simply VB minus VA. So that is simply 40I minus, oh, so this is 40J, right? So VB is 30I and minus 40J. Right, so this is simply the relative velocity. And we can easily calculate the magnitude. So to calculate the magnitude, we have to remember the triplet, 3, 4, 5. This is into 10, 30. This is into 10, 40. So what would be this thing? The resultant would be simply 30 square plus 40 square, which would be 50, right? So this is the magnitude. And what would be the direction? So this is ij. So tan theta would be how much? Tan theta would be 40 divided by 30. So theta is tan inverse 4 by 3, right? Oh, we don't have, okay. So we don't have, these are 50 kilometer per hour. But what would be, yeah. So let's say, what is this direction? Right, east of south. So east of south, and this is also east of south. So this is east of south. So we have to take the angle from the vertical, right? This is the angle. And what is this thing? So this is minus 40, right? So this is 40 and this is 30. So this is the direction, right? And if we say that east of south, so we are taking this angle, right? We are measuring from south. So this is theta. And what is the perpendicular then? So this is 30. So tan theta would be 30 by 40. And this theta would be tan inverse 3 by 4. So this would be the option. Right. Did you guys understand that why didn't I take the usual? Yeah. Arrange your video. So what is the problem with my video? Okay, let me, yeah. So this is the, yes, did you guys understand that why did I take, because why didn't I choose tan theta as 40 by 3, 30? Why didn't I take this one? Because in the options, we don't have this angle. They are saying east of south. So south, from the south, we have to measure, right? From the vertical, we have to measure. So then we have to take this theta, right? So that is why we have taken this and this as the angles. So that is why we have tan inverse 3 by 4. Is it clear, everyone? Is it clear? Yes, guys. So everybody has joined, right? Yes, everyone, is it clear? Why you guys are so silent? Is it
Yes,
clear?
sir.
Yeah, so whenever we have these kind of questions, relative velocity, so it is very easier to use the IJK formalism, right? This is very simple, IJK, and we are moving in 2 dimension only, so K would not be here. So only IJ. And this would make your calculation very simple. Right, this would make your calculation very simple. So always remember this. Use IJK whenever you can. So this was the idea of the 71st question. Now you guys can try this 78th one. Right. So please try this 78th question and tell me what you guys are getting. And this is a very complicated question. So 78th one is a very complicated question. Please try this one and tell me what is the answer that you guys are getting. So let me zoom this thing for you. And whenever you guys are noting anything down, please tell me so that I can fix the screen at that point. So who has not joined yet? I guess Madhya is still absent. Right. Yeah, try this question and I'll be back in a moment, right? So I'll be back in 9 minutes. And you can use whatever you have learned, relative velocity we have to find, right? So velocity of rain with respect to what? Rain we have to find out, right? So this is the thing that we have to find out. Either you use IJ or you use another method, right? So I'll be back in a moment, right? And the idea is that you have to use VR minus VT. This is the thing that you have to use. You have magnitude of VR, right? So you can calculate the magnitude. So either you use resultant formalism or you use IJK. Both will give you the result. But the important thing is that which one is easy to understand, right? So I'll be back in a moment, guys. Yes, hello guys. Can you guys hear me?
Yes, sir.
Yes, sir.
So nobody tried this question. Okay, so what was the doubt, right? Yeah, so let us understand this question. So, okay, so let us understand this question. So a train is traveling in a horizontal rail at the rate of 90 kilometers per hour. So let's say this is the train, right? Velocity of the train, this is traveling and it is 90 kilometers per hour. So this is kilometer per hour, answers are in meter per second. So we have to write this in meter per second. So what would be that, right? So magnitude is 90 kilometer per hour. So this is 90 into 5 by 80, right? This is 5. So this is 25 meter per second, right? And if I write the vector, so this would be 25 I have. Now the rain are falling. So let's say this is the vertical. Rain are falling in this direction, right? And this is making 30-degree with the vertical, right? So if we want to calculate, let me draw this with another color, right? So this is your ray. This is your x and y axis, right? And if we write it in IJK formalism, so let us first understand this with IJK formalism. So this is 30-degree, this is VR. So this with horizontal, this would be 60-degree, right? So how can we write VR? What would be VR, guys? Please tell me what would be VR. In IJK formalism, what would be VR? Yes, guys, what would be VR? Hmm? Magnitude is 12.5, right? So this would be 12.5 cos 60 I hat minus 12.5 sin 60 j hat, right? So this would be the vector. So what is this thing? 12.5 cos 60 is 2. And then this is 12.5 root 3 by 2 j hat. So this is VR. Now we want to calculate velocity of rain with respect to train. So this would be simply VR minus VT. Right. So how much is this thing? So this is 12.5 by 2 I hat minus 12.5 root 3 by 2 j hat. And this is minus 1225 I. So how much is this thing? So this is 12.5 minus 50 by 2 I hat and minus 12.5 by 2 and root g hat. So how much is this thing? So this is minus 37.5 by 2 I hat minus 12.5 root 3 by 2 j hat. So this is the relative velocity. Can you guys tell me that what is the quadrant in which this velocity is? What is the quadrant? Yes, guys, what is the quadrant this velocity is in?
Third quadrant.
Oh, yeah, you said third, right? Minus, minus. So third quadrant. So relative velocity is in this direction. Right, let me just draw the diagram. So this is in this direction. And we have to calculate this theta. Yeah, Maria, you are correct. So we have calculated the relative velocity and we have to only find out the direction and right. So we have to only find out the direction and magnitude. So magnitude would be how much? This is simply root of 37.5 by 2 square plus 12.5 by 2 and square root 3 square. So we see that we can take 12.5 because 12.5 threes is 37.5. So we can take 12.5 by 2 whole square outside. So this is 12.5 by 2. And then this is how much? This is 3 square. This is how much? This is 1 and then this is 3. So how much is this thing? So this is 12.5 by 2 and then this is 9 plus 3 root 12. So that is 4 into 3. So 2 will come outside and then this is root 3. So this is 25 root 3 by 2. Right. So there are two options, this one and this one. Both have 25 root 3 by 2 meter per second. Now what would be the angle? Right, what would be the angle? So we know that we have to calculate, right. So if we calculate tan theta, this theta is with the x-axis, right? Remember that this theta is with the x-axis. If we calculate ay by ax, so remember, this is your tan theta. Right, tan theta is with the x-axis, ay by ax. So let us find out this thing first. So what is this thing? This is 12.5 root 3 by 2 divided by 37.5 by 2. So this is 3. 2 is cancelled. This is root 3. So this is 1 by root 3. So tan theta is 1 by root 3, which means that theta is 30 degree. But this is with the x-axis. So with y-axis, this would be how much? 60 degree. Right, with vertical. So they are saying with the vertical. Right. So this is the option. Is it clear, everyone? Is it clear? And if you apply the vector formalism, right? So if you guys apply the vector formalism, that would be very complicated to understand. So this is your VT, this is your VR, right? And then you have to find out minus VT because we are calculating VRT, which is VR minus VT. So you find out minus VT, which would be how much? Which would be this thing. So this is your minus VT. And then you have to find out the resultant between them. So you draw the parallelogram. Right, so this would be your resultant. So this is VRT. But this thing is very complicated to understand. Right. And what we did was that we applied the IJK formalism and we found out this theta. This theta using AY by AX. This we found out 30 degree. So from vertical, this is 60 degree. So with IJK, this would become very easy to understand. Right? Is it clear, everyone? Is it clear?
Yes.
Okay, so quickly note it down, guys, and then we'll talk about, and this is a very important question. This is very, very, very important. So, yeah, you guys, please note it down and then we'll talk about the next one. I will do 2 questions from here, 2 or 3, and then I'll talk about quickly, I'll talk about circular motion and then I'll start laws of motion. The first topic. So we have to learn. Just remember that IJK formalism is pretty easy to apply. Yeah, whenever you guys have noted it down, please tell. So always remember whenever we are talking about two objects moving, right? So then we have to talk about the relative velocity. But if we are talking about river crossing problem, so then we have to find out resultant velocity. If we are talking about wind problem, then we have to find out the resultant. Otherwise, in rainman problem and in two cars moving, we have to talk about the relative velocity. Yes, noted everyone. And if you guys have a doubt in this question, please tell me.
So the question is a little bit cut off.
Oh, question is a little bit cut off. Yeah, so yes.
So question number what?
Question number 79. Yeah, so this was question number 79. Just noted. Whenever you guys have noted down, then please tell. Yes, noted, guys.
Yes, sir.
Well, okay, so now let us talk about the next question. Right, so I have to choose only two questions. So let me see. First, I will pick the simple one, and then we will talk about the tougher one. Okay, so no. So on inclined plane, we don't have that. So in inclined plane, we don't have projectile motion. So that is not. So that is in the advance, not in JEE mains, right? So projectile motion on an inclined plane, that is not there. In the that is in the advanced section, right? So don't bother about that. Yeah. Okay, so a man reaches directly across at 60 meters his velocity in still water. So let's do a simple question. Right, a person, rain appears to be magnitude, and yeah, rain is man walks, the rain drops with velocity of. Okay. Yeah, so let us quickly, yeah, let us do a simple question and then this question we will do. So this is a complicated one. This one we will do, but let us first do a simple question. So a man can swim in still water at, no, let us do this question, 87. So a man is crossing a river flowing with a velocity of 5 meter per second. So VR is given. Velocity of river is given. And remember that you are not using relative velocity in this one. So 5 meter per second. This velocity of river is given. He reaches a point directly across at a distance 60 meter in 5 seconds. Right. So this is the river, and he starts from here and reaches exactly the opposite point. And then you guys have to remember that in which direction he has to move, right? So this is his resultant velocity, right? This is his resultant velocity, and the velocity of the river is 5 meter per second. So you guys have to find out that what is the velocity of man in still water. Right? These are the things which are given. Quickly try this one. And yeah, if you guys get stuck, then we'll discuss this one. So this is an easier one comparatively, but the question that I'm thinking to do is a little bit complex one. But this one is easy one, right? So you guys have to find out, and the important thing is that he is reaching exactly. So this is the shortest distance. And we have talked about the scenario for shortest distance. Right. Quickly try this one and tell me what you guys are getting. Option B. So Yad is getting option B. Maria is also getting option B. And Tariq is also getting. Okay, Fadel and Shahid. What about you guys? right? So in the previous class, we talked about, Fadil is also saying B. Good. Yeah, so absolutely correct. So we are talking about shortest distance. This distance is 60 meter. This distance is 60 meter, time is 5 seconds, which means that velocity is how much? Which means that this VMR, this is 60 by 5, so this is 12 meter per second. So you have this velocity 12 meter per second, this velocity VR, and this is the velocity with which he started moving, right? Because he is covering this shortest distance, so he has to move in this direction. So we know that Vm square, that would be VR square. So this root is, yeah, so this VR square plus VMR square. So we know that this is a triplet, 5, 12, and this would be 30. So this is the correct answer. Yes, guys. Absolutely correct. So this is shortest distance. And if I say shortest time, then he has to move in this direction. So whenever I am saying shortest time, or whenever in the question it is mentioned that he has to cover shortest time, so then man will start from here. This would be the man's velocity. This would be the resultant velocity, right? And this is velocity of the river. So this is for shortest time. And this is for shortest distance. So whenever they say that it is in the this is distance, right? So whenever they say that this is shortest distance or shortest time. So when they say shortest distance, then the man has to move in this direction. When they say that it is in the shortest time, so the man has to move in this direction. And his resultant would be this. So then his resultant would be, right, Vm would be, or Vmr would be Vm square plus Vr square. So Vm would be, in this case, Vm square minus Vr square. So these are the two scenarios, right? In one case, this is hypotenuse. In other case, this is perpendicular. So you guys have to remember when which case we are talking about. So let's say in this case, right? So shortest possible time, which means that he has gone in this direction. So you guys have to be careful with these two terminologies, right? Whenever they say shortest time, this is the path. Whenever they say shortest distance, this is the path. So these are the two scenarios. Now we have talked about the river crossing problem. Then we can know this question, which is a little bit complicated. So this question, 85th one. A swimmer crosses a flowing stream of width W to and fro in time T1. Right. So he is moving to and fro. Right. Which means that he is taking shortest time. Right. So not shortest time, but shortest distance. So this is Vm, and then this is VMR. And this is Vm, and this is VR. Right. So a streamer crosses a flowing stream of width W to and fro in time T1. So this is W width. Right. So what would be the velocity of man in this case? What would be that? This would be simply root VMR square plus this would be VR square. right? So VMR is how much? VMR is VM square minus of VR square, right? Right, guys?
Yes, sir.
And also they have said that this VMR is, so this is the speed, right? And he moves to and fro. So how much distance he covers? So distance is how much? 2W. Time is how much? Time is T1. So if we calculate this VMR, what would be this thing? This is distance upon time. So 2W by T1. This is root of Vm square minus Vr square. So if we write time would be 2W divided by root Vm square minus Vr square. So this is one time, right? This is for to and fro motion. Is it clear? So this is case first. So this is moving to and fro. Okay. Now in the second case, he is moving. The time taken to cover the same distance up and down the stream is T2, right? So now the same distance, but the time is T2. But they are moving the time taken to cover the same distance up and down. So upstream, what is the velocity? Or what is the speed? What is the speed upstream? We know that the velocity of man is m, velocity of river is this. So what would be the speed upstream? Yes. What would be? This is your 10th standard problem. Upstream velocity, upstream speed. What is upstream speed? If this river is flowing in this direction, right? And the man or the object is moving in this direction. So this is called upstream, right? This is upstream. So what is the velocity in upstream? This river will oppose the motion, right? So what would be the speed, guys? This is 10th standard problem. Yes, tell me if you guys have. So upstream, Vm minus Vr, right? And what is the distance? Distance is W, right? Okay, so we'll talk about this thing, right? And then we have downstream. So downstream, what is the velocity? Vm plus Vr, distance is again W. So time in this case is W by Vm minus Vr. Time in this case is how much? W by Vm plus Vr. So total time is how much? This is case 2. So total time is W by Vm minus Vr plus W by Vm plus Vr. And they have said that this time, total time is T2. Right, so this is upstream and downstream. So one velocity is to and fro, the river, other is upstream and downstream. And then we have case third. So third case is what? Case third is if T3 is the time the swimmer would take to swim a distance 2W. So this is in the still water. So distance is 2W, speed is Vm, right? Speed is Vm, distance is 2W. So then what would be time? Time is 2W by Vm. And they have said that this time is T3. So these are the three cases, right? One is this one, the other one is this one, and then this is the third case. And we have to find out what among these four options, what is the relation, correct relation between T1, T2, and T3. So one is moving to and fro, the other is upstream, downstream, and the third case is still water. So did you guys understand this problem? Did you guys understand this problem? Okay, so now let us simplify this thing. T1, yeah, so let us simplify this thing. So what would be this thing? Should I simplify? Oh, so let me simplify. T1 square, this would be 4W square divided by Vm square minus Vr square. So let us keep this thing. And then we have this thing. So if we take the LCM of this thing, right, so what would be this thing? This is Vm square minus Vr square. And this is Vm plus Vr W plus WVm minus Vr. So Vr part will cancel. And this is T2. So what we will get? We will get 2Vm W divided by Vm square minus Vr square. And this is T2. And we know that what is this value? Vm square minus Vr square. Vm square minus Vr square is 4W square divided by T1 square. Right, so Vmw divided by 4W square. And then this is T1 square. And this is T2. Right. Now what is T3? T3 is, so this W will cancel. This 2 and this 2 will cancel. So what we will get? So 2W by Vm. Right. So what is this thing? This is divided by T3. So we will get what? So we will get T1 square as T2 into T3. So this was the question. Is it clear? So this was a little bit complicated, right? T1 square is T2, T3. So this was the question. Is it clear, guys?
Yes, sir.
Yeah, then quickly note it down and then we will leave this part. So then I guess resultant and relative, that is clear to you guys. So, but always remember, whenever we are talking about shortest time, then we are going straight. And whenever we are talking about shortest distance, Then we are talking, then we are going in the left direction to follow the shortest distance path. So that thing you guys have to remember. Yeah, whenever you guys have want me to scroll down the screen, please tell me. Yes, whenever you guys want me to scroll down the screen, please tell me.
Done, sir.
Done. Okay, then move down the aspects. Who's getting disconnected again? Tarif is getting this. Hello, Tarif. What is happening to your internet?
Yes, it's back to
Yes. Okay, no worries. So whenever you guys have noted it down, please tell me. Yeah, this question was a little bit lengthy one, but this was a nice question. Yeah, whenever you guys have noted, please tell me. Okay, so done. Yes, everybody noted.
yes, sir.
Okay, so then let us check if you guys remember this thing or not. So let me ask a very simple question to you guys. And then let's see that if you guys remember this or not. So the simplest question is this one. And then we'll move on to circular motion. So 86th one. A boat is moving with this speed in still water. So let's say this is whatever Vm we were writing. So that is Vb in this case. And then crosses a river of width in shortest possible path in 15 minutes. The speed of the river in kilometer per hour. So this is a very simple question, right? Shortest possible path they are saying. So please find this one out and tell me. You have this thing. This is the boat, right? And this is covering shortest distance, which means that the path that this boat or the velocity with which the boat has started. This is V boat. This is velocity river. This is velocity of boat with respect to river. Yeah, this saying 3, which is B. So yeah, there is saying option B. Maria is also saying option B. Right, only you guys have to calculate, VR. VB is given. So VB is simply VR square plus not so VR square plus VBR square. This is the thing. And you have to calculate VR square. So VR square is simply root of VB square minus VBR square. Right. You have already this thing you have to find out. Tarif is also getting B. Yes, Fadil and Shahid. What about you guys? This velocity, this distance is given. 1 kilometer is the distance. 1 kilometer is distance. Time is 15 minutes, which is 1 by 4. Time is 1 by 4 hour. Right. Shahid is also getting option B. And what about you, Fadil? So distance, time, you can calculate this velocity, you can put in here, and then you can find out VR. Why did I write VR square? So this is VR. So this thing you can find out. All these things, they are given. Yes, Fadil, what happened? Yes, so you are getting a triplet. 5, this is 4, the answer would be 3. Yes, Fadil, do you have any doubt in this one? Hello, Fadil, can you hear me? I guess. Okay, so Fadil is. Okay. Okay, so let us talk about this last part, which is the circular motion. And in the circular motion, I want to talk about these things you guys have already learned. So you guys have already learned about the angular distance, angular velocity, and the relation between the linear motion and the angular motion. And we are only talking about uniform circular motion. So this omega is fixed. This omega is fixed in uniform circular motion, right? So this velocity is related by cross product omega cross r, and its magnitude is omega r. And acceleration is simply omega square r, which is v square by r. But there is a very important relation that I want to discuss. This is very, very important. And so let's say the object is here, right? Initially the object is here, and now the object has reached this point. So it is making a theta degree angle, right? So let's say this is, so the angle between them is theta, right? This is V2. So if we write V2, right, V1 is, let's say VI hat. V2 is how much? V2 is V cos theta I hat plus V sin theta j hat. Right, so this is V2. And the question that they usually, so delta V is how much? Delta V is V2 minus V1. And this is V cos theta I hat plus V sin theta j hat minus VI hat. So this is how much? So V cos theta minus V I hat plus V sin theta j hat. And if you solve this thing, right, if you solve this thing, so what would be magnitude of change in velocity? Whenever they ask you this magnitude of change in velocity, so this is simply V cos theta minus v whole square plus v sine theta whole square. And if you solve this thing, so you'll get this thing. 2v sine theta by 2. So always remember this thing. This is very important. Very, very important. Okay. So this is a very important relation. Whenever the object is changing, what is happening? So only the magnitude of the linear velocity is not changing. That is v only. But due to the change in direction, the magnitude of the change velocity is changing, right? So change in velocity is there is a change in velocity, and the magnitude of change in velocity is this thing. So always remember whenever the angle is theta. Okay, is it clear? So just note down this part. Just note down this part, please. And we will do 2 questions, and then we will move on to laws of motion. Done. Okay, so remember this thing, right? Magnitude of change in velocity is this thing, 2v sine theta by 2. Okay, so let us do some questions, right? So let us do some questions. So you guys can see the application of this thing, right? The application of the formula that we just discussed. So the question number 60, right? Question number 60, quickly do this one. This you can do quickly, right? So quickly do this question, question number 60. So they have given the velocity, constant velocity, and they want you to calculate theta is also given 60 degree. They want you to calculate delta V magnitude. So this we have just discussed. What would be this thing? So Maria is saying 10 meter per second, which is B. Yeah, there's also same option B. Shahid is also getting B. Tarif also getting B. Fadil, what you are getting? You have to just apply 2V sine theta by 2. Right? All the things are given. V is given, theta is given. 2, 10 sine 60 by 2. Sine 30 is half. So this is 10. Right, yes. Good, everyone. Yes, absolutely correct. So this was this was about the change in velocity, and then we have these kind of. So again, the same question. Oh, let me just erase quickly, right? Yeah. So let me quickly erase this one. So this is the same question, right? And I will skip this one because you guys already know the answer, right? So let us skip this one. The ratio of angular speeds of minute hand and hour hand of a watch. Right, so let us, okay, so let us do this 113 question. Right, in this question, omega is given. And R is given. So find out V for this one. This is omega cross R. So whatever method you apply, either you apply the determinant method or either you apply the cyclic method. To find out the answer and tell me. What you guys are. Option B, this much quick. Yes. What you guys are getting. So this is omega cross R. IJK. This is omega and then this is R. I. Option B. So Shahid is also getting option B. This is minus, right? Yes. What about you, Tarif and Fadil? What about you guys? What happened? So you guys can check only one because you guys see that the options are different. So you can check yes, or you have wrote the answer. You have written the answer. Oh, Tarif, you have written the answer. Good, yes. Is Fadil here? Yeah, so we can only compare the first part, right? So minus 24 plus 6, that is minus 18. So this is the option. Good. And to start laws of motion as well. So this could find out the displacement, right? The magnitude of displacement of a particle moving in a circle of radius A with constant angular speed omega varies with time t. So you guys have to find out this thing, right? So this is a very important question. Try this at your home and I'll ask this question in the next class. Take the screenshot of this question. Yes, taken everyone. Okay, so then let us, yeah, and the rest of the questions are, so then let us move on to the next chapter, which is laws of motion. And the first thing or the first topic of laws of motion is, yeah, so the first topic of laws of the motion chapter is laws of motion itself, right? And this is particularly the second law of motion. First law talks about the inertia, that thing you guys already know. The second law is about the force, external force. Third law is action and reaction. So this second law, the first law is very important. The second law is very important, right? So which talks about the momentum and the external force. And these things you guys have already learned, that change in momentum is external force, momentum is mass into velocity, and impulse is the change in momentum. So you can also write F external as I by T. So impulse is simply the force into time. Impulse is force into time, but if you have a variable force, right? If this F is uniform, what is the uniform force? Oh, so I have two. Done. Okay. So we have two kinds of forces, right? Uniform and then non-uniform force. So if I have a uniform force, then what would be acceleration? Can you guys tell me? If we have uniform force, then what would be acceleration? So acceleration would be uniform also, and this would be constant. Right. So then we can apply the equation of motion, which was what we understood. Right. V is u plus at, s is ut plus half at square, v square minus u square, and so on. So whenever we have uniform force, then we can apply these things. We can directly get acceleration and then we can apply these things. But whenever we have non-uniform force, then we have to use calculus. So acceleration would be not uniform, right? Because F is dp by dt, and if mass is constant, usually mass is always constant, right? So if mass is constant, this is ma, right? So we can directly get acceleration from force if mass is constant, right? Because and P is mv, right? So this would be how much? M dv by dt plus v dm by dt. And if mass is constant, not the vector. So if mass is constant, mass is not changing with time. So this part is 0, and this gives you acceleration. But if we have the changing mass, as for the example of rocket. So in rocket, only the mass changing. So because fuel is burning and then mass is decreasing. So that is why in rocket system, right? In rocket system, this mass is changing. This relative velocity is not changing. So this part is 0. So for rockets, your upthrust force, right? So for rocket propulsion, this is your thrust force, right? And this is, in this case, the mass is changing. And then you guys have already learned about the conservation of momentum, which is P initial equals to P final. So momentum is always conserved, right? Momentum is whenever in collision or in all those things, so momentum is always conserved. And this is the thrust for rocket systems. So these things you have to keep in mind in this chapter, right? So if F is uniform, impulse is simply F into delta T. If F is non-uniform, then we have to use calculus. F is uniform, acceleration we can calculate, and then we can apply EOM. We cannot apply equation of motion in here, and then we have to apply the calculus in here. So these are the things that we have to keep in mind in this chapter. And there's this free body diagram. Yeah, so that we'll also talk about. Okay, so this is about the laws of motion and the first topic, which is the second law of motion. And you have conservation of momentum. So all these things we will use in this chapter. So let us do some calculations, and then this would become easy, right? So let us do the case of using the uniform force. So first question I will do, and the second one you guys will do, right? So you guys can see this force and tell me what kind of force is this? F is only 40I plus 10J. Do you have any parameter X, Y, Z in here? Do you have any parameter X, Y, Z, T, something like that? Anything which is function of time, space? So this is a uniform force, right? This is a uniform force. So then we can apply the equation of motions, right? Because uniform force is uniform, then acceleration would be uniform, and then we can apply the equations of motion. So let me quickly do this problem, and then I will give you this question, right? So F is given, which is 40I plus 10J. And this is mass into acceleration. So acceleration is F by M, which is simply 40I plus 10J divided by 5. So this is 8I plus 2J. So this is your acceleration, and you can see that this acceleration is also uniform, right? It is not depending on the other parameters, time or XYZ space. So this is uniform. You can apply equation of motion, and you have to find out the position vector. So you have to write in the vectorial form. So R is ut plus half at square. This is starting from rest. So this part is 0, and you have only half at square. Time they have given 10 seconds. So A, which is 8I plus 2J, and then this is 10 into 10. So this is 550. So 50 into 8, 400, and then 50 into 200. So this is the position vector at 10 seconds. So this was a very simple question, right? 400 rise plus 100 G. So this is the question. Clear, everyone? Yes, guys, clear. Good. So then please do this seventh one. Using the same idea, please do the seventh question. So please do the seventh question. And remember, how do we write the coordinate? So the position vector of this coordinate would be what? 8I plus bj plus 20k. So from coordinates, we can always write the vector. So this is the position vector. Yeah, do this problem and tell me what is the answer that you guys are getting. Yes, guys, any answers? So Maria is saying 12. What about rest of you guys? What happened? Okay, so let us see this again. Acceleration is how much? F by m. Right, so what is this thing? This is 2 by 2, so I hat plus 3 by 2 j hat plus 5 by 2 k hat. So this is your acceleration. Again, it is starting from rest, right? And after 4 seconds, so t is 4 seconds. So r is simply half at square. So half, this is I plus 3 by 2j plus 5 by 2k, and then 4 into 4. So this is 8. So this would be how much? 8i plus 8, 2 and 2 will cancel, and this is 4 3s are 12j. And then again 2 and 2 will cancel, this is 20. So if we compare with this one, right, B is how much? B is 12. So B would be 12. Right. So yeah, B would be 12, guys. Is it clear, Fadil and Tarif? Where did you guys get stuck? Yes. Okay, so quickly note it down, right? Quickly note it down, and then we'll talk about. Oh, yes, your network is fluctuating, Tarif. So your voice is lagging a lot. Quickly note down this part, Fadil and Tarif. And I guess Iyad got disconnected also. So your network of yours is working very poorly, right? And I guess, yeah, so quickly note down this part, Tarif and Fadil. And then we will talk about the next part. So what happens when the acceleration is not uniform? So that question we will do. Yes, noted, Tarif.
Yes, sir.
Okay, so now let us talk about the non-uniform acceleration, right? So this is the question related to the non-uniform acceleration, right? So we have non-uniform force, right? Which gives non-uniform acceleration. And they are only talking about, right, whose direction is constant. So direction is constant. So we'll only talking about the magnitude because direction is constant. So this is moving in same direction. So let's talk about the magnitudes only. So F is given, right? F is given and we can calculate this A. So A is how much? F by M, right? So this is how much? And the mass is capital M. So let us write this is F naught 1 minus this is how much? So this is T square minus 2TT plus T square divided by T square and divided by M. So how much is this thing? F naught, and then this is 1 minus T square by T square And then this is plus 2tt by t square. And this is minus t square by t square. So this is 1 and 1 and 1 cancels. This and this cancels. So what do we have? We have f naught by m. And this is, let's write the positive part first. So this is 2t by t minus t square by t square. So this is your acceleration, and this is function of time, right? So this is not uniform. So we cannot apply the equation of motion. So we have to use the idea of calculus. So what do we have to find out? The force acts only for the time interval 2t, right? The velocity v of the particle after time t. So how acceleration and velocities are related? We know that A is dv by dt, right? So then what would be this thing? We have to find out v. So dv is a dt, and then we have to integrate both the sides. So limit is starting from velocity. So that is initial velocity and then final velocity. Starting time is 0 and the final time is 2t. So these are the limits, right? So this is simply v and v minus 0. So this is simply v, and this is 0 to 2t a dt. A we already know. A is this thing, right? So if we solve this thing, what we will get? 0 to 2t, and f naught by m, that is constant, so we can take it outside. And this is 2t by t minus t square by t square, right? Dt. So what would be this integral? Let us write it in here. So v is f naught by m, and this integral is 2t square by t, and from what, 2t to 0, right? And minus of, this is t cube by 3. T cube by 3 t square, again from 2t to 0. Right, so what is this thing? F naught by m, and then this is, so 2t square by 2, right? So this 2 cancel, and we have to put 2t in place of t. So this is 4t square divided by t. This part will cancel. Minus how much is this thing? We have to put 2t. So this is 8t cube divided by 3t square. So this part will cancel, and we have what? We have f naught by m. This t will also be common, and this is 4 minus 8 by 3. So how much is this thing? 12 minus 8 by 3, so 4 by 3. 4 f naught t by m. So this is the velocity. Right, so this would be the option. Is it clear? So this is the example of a non-uniform force. Is it clear, everyone? Yeah, if you guys have any doubt, please tell me. Otherwise, quickly note it down. So we have to apply calculus whenever we don't have a uniform acceleration. So if we don't have uniform acceleration, we have to apply calculus. If we have uniform acceleration, then we can apply equation of motion. So that is the key idea, right? Quickly note down this thing. and then we will move on to the next question. Maria has noted. What about you, Tarif and Fadil? What
Yes,
about you
noted.
guys? Noted. Okay, so yeah, there was another question that was related to conservation of momentum. So many people got disconnected. So we'll stop here and we'll continue from here in the next class, right? So bye guys, bye. Bye everyone. Allah Hafiz,
Thank you,
Allah
sir.
Hafiz.
Thank you, sir.
Welcome salam, welcome salam.